We're going to do lunar eclipse and then the sun and then the tides. When the moon is full and on the plane of the ecliptic, the Earth's shadow will intersect with the path of the moon and cause a lunar eclipse. So, full moon, sun on my left, moon at the full position, and it's on the plane of the ecliptic. Therefore, it is entering the shadow cast by the Earth. This can occur only when the sun, Earth, and moon are aligned in syzygy exactly or very closely so with the Earth in the middle. The type and length of an eclipse depends upon the moon's location relative to these nodes, these lunar nodes, these points of intersection with the plane of the ecliptic that happen every lunar cycle, but only occasionally in the full or new phase. Full giving us a lunar eclipse. 3 types of lunar eclipse. Penumbral, where the full moon enters the Earth's penumbral shadow with the Earth in between the sun and the moon, full moon phase. Partial, where part of the Earth enters the umbral phase. The umbral is a set portion of the Earth's shadow, and you can see this lunar eclipse. The penumbral lunar eclipse, you don't really notice that much. It's just a diminution in light, a lessening in the intensity of the full moon's light, but you can't really perceive it that well. And then a total lunar eclipse where the entirety of the moon enters the umbra of the Earth's shadow. There's a code for reading the lunar eclipse when it's umbral, where the P1, U1, U2, U3, U4, P4 indicate where the moon is in relation to the penumbral shadow, the umbral shadow, entering and leaving. We'll have a lunar eclipse on the 22nd, on 2022 on May 16th, 2022. 2 years from now, you'll be a sophomore in high school if you're looking at this in January of 2021. Is that right? Oh, no, you'll be a freshman, not a sophomore. Oops. So next spring, a year after this spring. And if you're up at 11:11, so 5 hours before this Greenwich Mean Time of 4:11 or Universal Time, you'll be able to see the moon at its greatest moment of eclipse. And you can see that's going to be possible for us here in the East Coast of the United States, and all the people in the white here will see it. And one of the things that makes lunar eclipse more accessible is because everyone in this whole area down here sees the same thing. You get the same experience. The moon is just either higher or lower in relation to the horizon. Whereas with a solar eclipse, totality, if we remember, is only a narrow band of the Earth's surface. So any location on the Earth will have many more lunar eclipses over the course of an individual's lifetime than solar. In fact, in some locations on the Earth, you may never get a total solar eclipse in a person's lifetime. Lunar eclipse, then sun, Earth, moon passing into Earth's umbral shadow for totality. A total lunar eclipse can only occur during what moon phase? Full, new, or quarter? Well, the answer is the full moon. Why does a solar or lunar eclipse not occur every month? Because of the moon's orbit tilted to the plane of the ecliptic by 5 degrees. So here, orbiting up above the plane of the ecliptic at that maximum of 5 degrees, then descending through the lunar node where you could have an eclipse if you were in the right phase. In this diagram, no. But over here, we've descended into the new moon position. Therefore, the moon can cast a shadow on the Earth and you can have a total eclipse. Then, coming back up, ascending through the node and coming around, descending back into the full moon position at the lunar node, a total lunar eclipse. So it's this tilt of the moon's revolution around the Earth, 5 degrees to the plane of the ecliptic. And here you can see a diagram. Here it's below the plane of the ecliptic by 5 degrees, and here above. Over the course of 2 weeks, we could see how the moon changes at the same time of day. The sky at sunset. Just before sunset, you can often see the waxing crescent, then getting bigger, then at sunset eventually a quarter moon, and then finally what we'll see next Thursday, if it's clear, a full moon rising as the sun sets. The moon and the tides are the alternate rising high tide and falling low tide of the sea, either once or twice each day depending on location. Tides are very long waves that are noticed most prominently where the land meets the sea. Now, what one can try to imagine is that at any given moment, as the moon revolves around the earth, a portion of the earth is underneath that moon, rotating underneath that moon. And where it is ocean that rotates underneath that moon, there is a bulge of water that's risen up, pulled up by the gravity of the moon and the sun. When that bulge reaches a point where the land meets the sea, that water that's risen has nowhere to go but up and onto the land, high tide. As the earth rotates away from the bulge, the water drops, low tide. So tides are generated, that bulge is created by the gravitational force of the sun and the moon, and then the centrifugal force / inertia that is caused by our rotation in combination with the gravity, where water flows towards the side opposite the moon because of the Earth's center of gravity shifting towards the side of the Earth nearest the moon. A diagram of that shows that when the moon is in any when the Earth is in any part of the Earth is directly under the moon's force, the center of mass of the Earth changes slightly. The gravity, therefore, is greater here. The water bulges. But likewise, on the opposite side, the gravity is now somewhat reduced and water bulges there too. So in the course of one 24-hour period, most locations on Earth will experience 2 high tides 12 hours apart, and at right angles to the high tide, in terms of our rotation, 2 low tides. The moon has twice the gravitational pull of the sun because it is so much closer to the Earth. Thus, its impact on the tides is greater over the course of a lunar cycle. So the sun is 10 million times bigger than the moon, but the moon is 390 times closer to the Earth than the sun. The sun is that much further away. And we can't even really show it on a diagram, but the moon and the Earth are linked together. They are tied together. Tidally locked, actually, is the way people describe it, whereas the sun is just so far away that its gravity doesn't have as much impact. Now, if it was the sun and no moon, we would still have a tide. So if we spin this and put just the sun here, no more moon, then every day at noon, solar noon, you would have a high tide, and every day at midnight, a low tide. But because we have this moon also interacting with the Earth in a different position every day over the course of a lunar cycle, you get these various times of high tide and low tide at different locations where the sea meets the land. The lunar cycle then is driving the tidal system. Without the moon, there would be no appreciable tides. And forces that influence the tides, the effective centrifugal force on the ocean, a result of the Earth orbiting around the center of gravity between it and the moon. Let's watch this diagram carefully. We see up in the left tides that have particular name. Well, when the moon is at a right angle to the sun, it's called a NEAP tide. When the moon is lined up with the sun, it's called a spring tide. So twice a month, we have tides that are higher high tides and lower low tides. Those are the spring tides at the new moon and full moon position. And twice a month, when the moon is at a right angle to the sun, we have tides that are not as high and not as low. Those are called your NEAP tides at the first quarter, and here, the last quarter. And if you look at the diagram, you can see how it's been illustrated. The orange is the amount of force that the tide the amount of tide caused by the sun's gravity. The gray that which is caused by the moon, and the green, the combination. So just watch the gray, the orange, and the green as they change over the course of a lunar cycle. In the spring position, new and full moons, it's a sum of two forces. But in the NEAP position, first and last quarter, the two forces are at odds, and thus overall the tide is lower. So a NEAP tide versus a spring tide. There are three major tide types in terms of frequency. That is how often they occur. You either have a semi-diurnal tide, which is a tide that occurs 2 times a day high and 2 times a day low. A diurnal tide, which is 1 high and 1 low, like in the Gulf of Mexico here. Or a mixed semi-diurnal, which is 2 highs and 2 lows on any given day, but they're not the same height. Whereas in your semi-diurnal, the 2 highs in any 24-hour period and the 2 lows in any 24-hour period are more or less the same. So let's look at a semi-diurnal in New York City. This is the kind of tide we have. 2 highs and 2 lows in a given day, and you can see they're relatively similar, particularly the lows. They're all a little bit below what is called mean low water, or sea level here. They're a little bit lower than that, and then they go up about 4 to 6 feet at high tide, and this is called mean low water, right? That's what they're measuring from. That's what the MLLW. So a high tide, 6 hours later, a low tide. A high tide 6 hours later, followed by another low tide, and then a second high in a 24-hour period. Although I should have started here with low to high to low to high. 4 tides in a 24-hour December 3rd period. This was that same location during Hurricane Sandy, where we can see that the storm, which happened during a full moon, a spring tide, caused the tide to be about 9 feet higher than normal. 9 feet higher than normal, which of course meant that there was terrible flooding in many locations along the shoreline of Manhattan and off in Brooklyn. Coastal flood elevations during the hurricane were the highest in the history of the city. The storm tide was at 14 feet, with the surge 9.2 feet coming close to high tide. This is about 5 feet higher than most of the seawalls, so we weren't protected by that storm. And if storms, because of climate change, are getting more frequent and more severe, then that is a concern. Tides that shift from high to low every 12 hours are said to be diurnal. Once every 24 hours a high, once every 24 hours a low. And you can see that's the case in the Gulf of Mexico, here in Shell Beach, or at Shell Beach, Louisiana, with a high on the 27th of August at 16, and then at the next day, slightly later, about 50 minutes a day later, a high from high to high. Tides that change from high to low every 6 hours, but have a set of higher low tides and lower high tides in that same period. So the tides aren't matching in the same way they did here for New York City. We call those tides mixed semi-diurnal. The 2 highs aren't the same, and the 2 lows aren't the same. Here's a low, 12 hours later, another low, not the same low. Here's a high, 12 hours later, another, not the same high. This would be the case along the west coast of the United States. Here's a very famous location, the Scripps Institution for Oceanography. If you're interested in marine biology or oceanography, this is a great place to get a job or to work during college, or many opportunities out there. And you can see these funny mixed semi-diurnal tides. Why are the same diurnal higher-low tides 24 hours and 50 minutes apart, not 24 hours? And it's the same question for semi-diurnal below. Well, it's because the moon is going around the Earth every day, moving from a position, say, in its new position, 13 degrees per day, 13, 13, 13, 13, 13, 13, 13, 13, which means that the high tide you have today, 24 hours from now, will be in a different position in relative to time. It's going to take you 50 minutes longer to rotate to that bulge that the moon is causing under it. So the moon moving every 13 degrees, and likewise we're also moving 1 degree per day. When the tide is rising, these are three words you should probably be familiar with. From low to high, the tide is said to be in flood, or it is a flood tide. When the tide has stopped rising, but it has not yet turned towards the low, it's said to be a slack tide. So at a slack tide, you could be paddling easily in either direction. When it's a flood tide, you can't paddle, say in a kayak or a canoe, against a flood tide. It will just push you in the direction it wants to go. Now the tide is falling, you can paddle with the falling tide out, or if you were trying to move up against it, that would be different, and that's called an ebb tide. So when the tide is falling from high to low, the tide is said to be ebbing. It is an ebb tide, or the tide is on the ebb. So rising, in flood. In between rising and falling, slack. Falling, on the ebb, ebbing. In New York City, great place to watch the action of the tides is around Randall's and Ward's Island, because here, for instance, the tide races in from Long Island Sound at high and so can move in this direction, but then it can be pulled out in that direction at low tide. But meanwhile, you can also have a high tide coming up the East River. So the area around, particularly this neck of the woods, right in here, Hell Gate, always fun to watch the tide. And I have some videos I'm going to post that will illustrate how rapid the tide can move through that area of New York Harbor. And this is called Hell Gate because so many boats, particularly in the 17th, 18th, and part of the 19th century, could not tolerate the conditions and sank. Here again, the tide comes up from the East River, say at noon. The high tide in this area is 3 hours later. Just takes that much longer for that bulge to work its way around the land into the Long Island Sound and down towards the city. Meanwhile, so water 3 hours later is plowing down this way, right? While the tide here was high 3 hours ago and is beginning to go out, so you can get a rushing river of water down to the south. And the opposite is true as this tide rises into an ebbing tide up here in the Sound. So the specific definition of spring tides: when the moon is in the new and full position, the direct gravitational of the moon, and to a lesser degree the sun, creates a spring tide. Spring tides are the highest high tides and lowest low tides of the months, the greatest tidal range. Neap tides, when the moon is in the first and last quarter. The gravitational effects of the moon and the sun are at right angle to each other, and the tide's overall height is diminished. Neap tides are the lowest high tides of the month, and they have the highest low tides. So the range between the two, high and low, is very narrow. And this is happening at your first quarter and your last quarter. Here's a picture of that. The new moon with a spring tide and a range from low to high, followed a week later by a neap tide and a very much smaller tidal range, followed a week later by a spring tide and a much higher tidal range, followed a week later, neap, spring, and so on. Tidal range can be quite dramatic. Here in the British Isles and the Republic of Ireland, you can get tidal ranges that vary from 10, 11, 12 feet between low and high tide. This makes tides very dangerous, particularly if you're at the seashore or you're not aware with a boat, for instance. Let's say you had been planning to leave when you came upon your boat in this situation. You're not leaving until the tide comes in. So you might not be leaving for 6 hours. Likewise, you thought you were going to go crabbing off on the mud flats. Nope, you're not crabbing, or you're not going to get clams or cockles because you have to wait for the water to go out. So here's about an 8-foot range in Monterey Bay in California, high tide, and then you can see how the water's going out. High tide, you can see how the water's going out. High tide, you can see how the water's going out. And that, of course, is something that you need to be aware of when you're at the seashore, when you're doing activities at the seashore. You must take into account the tide. If you go kayaking You must take into account the tide. If you're not aware of when tide is going in or out, you can find yourself in a very tricky situation where you're being swept out to sea, for instance, in a little kayak, unaware that it was a tide that was on the ebb. And thus you have to either figure out how to move in a safe way against that tide or at right angle to it, or wait to come back during the flood tide. One of the other interesting things about tides is that they set ownership boundaries for property along the shore. So if you live, for instance, in these states, your ownership line is at mean high water. So if you had a house here, you own down to the average high tide line on the shore. Not below it. The state can come on and do whatever it wants in here. If you're in Texas, you get a little bit more land. You control a little bit more. And if you're out here, actually you own less in Texas, sorry. If you're in Delaware or Maine here, you own all the way out to mean low water. And the difference between Texas and these other states was that this is mean high water. This is like a particularly high tides that can happen in the course of a year. And then as we go out, we can see that the state controls some of the land beneath the water, and then you get out to what the nation begins to control until finally you're in the waters called the high seas, which have their own rules. In New York City, we're in what's called the intertidal and estuary, which is a rich zone for biological diversity and breeding ground for many larger organisms that use the protected waters here. And the tidal ranges can create fantastic organisms with amazing adaptations to the exposure to the air during low tide and the being covered by the water during high. And not to mention, some of the organisms are just very beautiful. Some final moon realities. After colliding with the Earth, the moon was significantly closer to the Earth. What might the consequence of this have been? The moon is moving away from the Earth right now at a rate of 3.8 centimeters per year. What might the consequence of this be? And how might the collision with Theia have affected the Earth's rotation? Some final paintings that just give you a sense of the tide. People have always been fascinated with it here. Low tide people are gathering things along the shore, either things to eat. In this period of history, there were many shipwrecks, so at low tide you could find things. This is a good part of the world in the British Isles to find fossils along these shorelines. So low tide was a tide of activity along the shoreline, but you always had to be aware of high tide because the high tide could come in 9-10 feet above mean low water. Here's some people on the Baltic Sea at, looks like maybe low tide, enjoying the sunset or a moonrise. Here's somebody who's adapted to the tide. The water is dropped. They knew that would happen. The ship is on its side waiting for the tide to come back. Meanwhile, let's build a fire and have something to eat. Or we're fully aware that tides have enough of a range that we can just beach our fishing boat at low water and wait for the tide to come in and then go out and do our job. Or at low water, we want to go collect. These are people collecting cockles or snails on the shoreline of the United Kingdom in the 19th century in a famous painting by J.M.W. Turner. Great painter. I have some paintings of his at the Metropolitan Museum and at the Frick Collection in New York City. So if you ever get a chance to see a Turner painting, always worth it. A man who loved to paint the beautiful light of the late afternoon, evening, and in the morning. Here's some moons and size comparisons with planets in our solar system. Here's the Earth and Venus and Mars, and then our largest moon in the solar system, Ganymede, followed by Titan, Callisto and Io, our moon near the size of Europa, Triton, these all bigger than Pluto, that fugitive planetesimal, and then these moons of other planets in our solar system. And with that, I think we're pretty much finished. Hopefully this worked. I've tried now several times and haven't had luck. We'll see.